We can also calculate present values from some future amount, and we call that process of computing present values from future cash flows, we call that discounting. We're discounting some future value to a present value, and it's based on the idea that a dollar today is worth more than a dollar tomorrow. Discounting is the inverse of compounding, and the interest rate that we use to discount is often called an opportunity cost. We may hear it also called a required return or the cost of capital. This is the discount rate or the interest rate that we're using to convert that future value to a present value. We can use the basic time value of money. Well, this is the same formula that we had before for compounding, where future value is equal to the present value multiplied by 1 plus the interest rate raised to the number of periods, except we've algebraically rearranged it. So for compounding, finding future values, we're taking the present value and multiplying it by this factor of 1 plus the interest rate raised to the power of n. And discounting, we're taking the present value to compute that, we're taking the future value and dividing it by this factor of 1 plus the interest rate raised to the power of n. So let's look at a spreadsheet. We have a future value, this is the amount to be received, of $100 at a compound interest rate of 10%, and we want to look at present values with different interest rates. So if we had a 1% interest rate, the present value of $100 to be received in 1 year, so in 1 year, that would be $99.01. So if we invested today $99.01 at 10% interest compounded, we would end up with $100. Now the present value of $100 to be received in 2 years is $98.03, and the present value of $100 to be received in 10 years at a 1% interest rate is $90.53, and the present value of $100 to be received in 20 years is $81.95. And then we can compare that 1% to different interest rates, 5%, 10%, and 15%. So let's look at the 10-year period. The present value of $100 to be received in 10 years, so $100 in 10 years is equivalent to $61.39 if our discount rate is 5%. If our discount rate is 10%, the present value of $100 to be received in 10 years is $38.55. And if our interest rate is 15%, the present value of $100 to be received in 10 years is $24.72. And notice that the higher the interest rate, the lower the present value. So we have an inverse relationship between interest rates and present values. The higher the interest rate, the lower the present value. And this concept is going to be important when we get to valuation of stocks, bonds, and investments within the firm. Let's take a look at this relationship on a chart. So 1% interest rate, we can see that the present value of $100 to be received in 20 years, that was about 80 some odd dollars. And we saw this before, the present value of $100 to be received in 20 years when our interest rate is, green here is 15%, is like $6 or $7. The higher the interest rate, the more we see that exponential decay. And the lower the interest rate, this is not really a flat line, just our eyes can't really pick up that there's a slight curve to that line. We can kind of barely see that exponential curve at 5%, but it really shows up at the 10% and 15% levels. So to summarize, the higher the interest rate, the lower the present values. Also, if we wanted to know the present value of $100 to be received in 20 years at 15% interest, if you look up here at the cell that I've used, I'm in this cell, I'm using the time value of money formula. So you'll recognize that cell C2, that is the future value, $100, it's in blue, so blue right here, divided by 1 plus the discount rate in red, so 1 plus the 15%, raised to, and in purple here, the 20th power. So this is just basically our time value of money formula that we just saw on the previous slide. Excel also has a function called PV that calculates the present value when we tell it the interest rate, the number of periods, and the future value. So Excel can directly calculate that for us. We can also use the financial calculator. To use the financial calculator, let's just start clearing out. So hit second, and then clear, second, and then this clear here in the lower left-hand corner. And then to use the time value of money keys, and this time value of money keys, you'll notice here in the gray, so I'm pushing these here, those are the time value of money keys. To use them, we want to first start by clearing the memory of this time value of money key. So hit second, and then above the FV, you'll see where it says clear time value of money. So this is an app that I purchased for my phone. You can also get a physical calculator. This is an app based on the Texas Instruments BA2 Plus calculator. Again, the details of that are in the course syllabus. So if we want to find the present value of $100, so $100 received in the future, so I'll hit 100 and then the FV button, over 20N, so I'll hit 20 and then the N, and I don't have any payments here yet, so we'll hit 0 and then payment, and the interest rate was 10%, so I'll push 10 and then the interest rate, and then hit this compute, this button in the upper left hand corner, hit compute, present value, and that will give me a present value of $100 received 20 years in the future at a 10% interest rate. At a 15% interest rate, I'd hit 15, I/Y, compute, present value, and I get $6.11. These are the same numbers that we got using Excel. Our basic time value formula for compounding, future value is equal to present value multiplied by 1 plus the interest rate R raised to the number of N. We saw that we could rearrange that for discounting to find the present value is equal to future value divided by 1 plus the interest rate raised to the number of periods. So there are 4 inputs. If we know any 3, we can calculate the 4th. So for example, if we wanted to know the rate of return R, that we would need to accumulate $100,000 at the end of 40 years, if we invested $5,000 today, that would be future value divided by the present value raised to the power of 1 over n minus 1. So for this particular problem, 100,000, the future value divided by the present value, 5,000 raised to the power of 1 over 40 years, minus 1. We do this calculation, and equals about 7.8%. We could also do this problem in Excel or on a financial calculator. And on the financial calculator, I'm going to hit clear a couple of times, hit second and clear time value of money. Again, that's over the FV. And if I invested $5,000, now using a financial calculator or Excel, we have to tell Excel or the financial calculator the direction of the cash flow. So if we invest $5,000 today, that's a negative cash flow. So negative 5,000 would be the present value, and we'll receive $100,000 at the future, so that would be a positive future value. We don't have any payments on this particular problem. When we get to the annuity problems, we'll have payments. And we had 40 and then N, and now we want to know what rate of interest we would have. We would hit compute and then the I/Y, 7.78%. So whether we work it out by hand, we use Excel, or a financial calculator, we get the same answer. Here I just rounded off to 2 decimal places. If I'd have taken it out all the way, it would have also been 7.78%, the same as with the financial calculator or Excel, just a little bit of rounding difference. So we've used the time value of money formula to compound, finding future values, to discount, finding present values, to find the rates of return. Now we do a 4th type where we're looking at N, the number of periods. So how many years will it take to double your $5,000 investment if you can earn an 8% annual return. So how many years will it take to double our investment? So second, clear time value of money, and then hit the lower left hand. We want to calculate N, is what we're looking to calculate. We have an interest rate of 8%, 8 interest rate. We have a present value of $5,000, so we want to make that a negative. Again, the calculator and Excel need to know the direction of the cash flow, so we'll assume that we're investing $5,000. We want to double that to a future value of $10,000. Again, that would be positive because assuming we're receiving the $10,000. 0, and then payments. We don't have any payments. And then we can compute N, and it's about 9 years. We can also use Excel. Present value, negative $5,000. So just like the financial calculator, we have to tell Excel the direction of the cash flows. So to double it, that would be $10,000. We'd be receiving $10,000 in future, so we treat that as a positive. Interest rate of 8%. And Excel has a function called NPER that we can use to calculate the number of periods. And you can see here in the blue, the first thing it asks is the interest rate. Then in red, it asks the present value. Then in purple, it's asking the future value. And then it calculates for us the number of periods. So it takes about 9 years to double our investment at an 8% interest rate. And then we can see if we had a 1% interest rate, not surprisingly, it'd take longer, about 70 years. If we had a 20% interest rate, it wouldn't take very long to double our money. It'd only take 3.8 years. And at 8%, it takes about 9 years to double our money. We can also use something called the rule of 72. I say can because we don't use it too much today, but in the day before calculators, computers, and all of that, doing these type of calculations was difficult. There was an approximation rule called the rule of 72 that would tell you how long it would take you to double your money. And to use it, it would be real simple. You would just take 72, the number 72, divided by the interest rate. So if you had an interest rate of 10%, 72 divided by 10% would be what, 7.2 years? So it's not exactly 7.27, but it's a pretty good approximation. Also look at a chart. I'm going to look at the chart here. We look at the number of years to double our investment. So our interest rate is here on the horizontal axis. And on the vertical axis, we have the number of years to double of our investment. So as we saw, if you only have an interest rate of 1%, it takes you almost 70 years to double your investment. But if you had an interest rate of 20%, it wouldn't take very long at all. And you can kind of see here, when it comes to doubling your investment, you get to around 14 to 20 years, it's pretty quick to double your investment, only about 5 years or so. So again, we do not see straight lines because of the exponent in our time value of money formula. We have exponential growth.